Okay, linear pairs and vertical angles. So we looked at this briefly, but just a reminder of the angle addition postulate. The angle addition postulate basically says that we can add two adjacent angles together to find the sum of an entire angle. So for example, if we wanted to find the measure of this entire angle right here, more specifically angle ADC, what we could go ahead and do is use the angle addition postulate, which tells us that we can add our two individual angles together to find the entire angle. So that would look like ADB is equal to 50 plus BDC is equal to 85. And by adding these together, we can find the entire angle of ADC. So when we add this together, we get is equal to 135 degrees. And so therefore we can say that ADC is equal to 135 degrees. So basically what this is saying is that the measure of an angle created by two or more adjacent angles is equal to the sum of the measure of the individual angles. And then just a reminder, adjacent angles are basically angles that share a common ray. So angles that share a common ray, or just angles that are right next to each other. Okay. Now we're going to look at linear pairs. So what is a linear pair? Well, a linear pair is basically two adjacent angles whose non-common side are opposite rays. So here we have two adjacent angles, right? Those are angles right next to each other. And they are opposite rays because they face. Yes, do you have a question? Do you have a question, Gabriella? It was an accident. No? Okay. Or you can just put it in the chat if you do. So a linear pair is two adjacent angles whose non-common side are opposite rays. These would be the non-common sides, and they're opposite rays because they face opposite directions. So what are linear pairs? Well, they're basically two adjacent angles who, when added together, equal 180 degrees. Okay, so for example, let's say that A was equal to 100 and B was equal to 80. Well, those would be linear pairs because they would equal to 180 degrees, right? 100 plus 80 is equal to 180 degrees. So we're going to see this. So what are linear pairs, or how are linear pairs created? Well, linear pairs are created when two lines intersect. They create a number of linear pairs. Linear pairs being two adjacent angles whose non-common side are opposite rays. So whenever we have two lines that intersect, we get different pairs of opposite rays. And so I'm going to go ahead and show you the different pairs that we have here. We have BAC and CAD. So those would be my linear pairs. We have BAE and EAC. So those would be my linear pairs. And I have EAD and CAD right there. So basically, linear pairs are two adjacent angles who have opposite rays. But what we notice is they also share a line. So for example, let me go to the last one we looked at. They are known as linear pairs because they share that line. And so that's why when you add them together, you get 180 degrees. Okay. We also are going to look at today what are known as vertical angles. Vertical angles are opposite non-adjacent angles who are formed by two intersecting lines. So non-adjacent are those that are not right next to each other. So adjacent are those that are next to each other. Non-adjacent, those which are not right next to each other. And vertical angles are opposite angles formed by two intersecting lines. So whenever we have two lines intersecting like here, we have opposite angles that are formed. And the relationship between our vertical angles is they are congruent. So for example, here is a set of vertical angle pairs. They are non-adjacent, they are not next to each other, and they are also opposites of each other. And so therefore they would be congruent. Here's another pair of vertical angles. Again, they're non-adjacent, they're not right next to each other. They don't share a common ray. And they are opposites of each other, okay? So here are some more examples. When two lines intersect, they form two pairs of vertical angles. So I'll show you what those are. So we have EAB. Its opposite angle or vertical angle pair is this one. And then we also have CAB, and its vertical angle pair is this one. So vertical angles are opposite angles, and they are also congruent to each other. So say that I knew that EAD was equal to 70. Well, because its vertical angle is CAB, this would also be equal to 70. Say I knew this was equal to 210. Actually, let me change it. 110. Then this would also be equal to 110. Okay. So this takes us into the vertical angle theorem, which basically says if two angles are vertical angles, that they are congruent. So if two angles are in fact vertical angles, opposite angles of each other, then they must be congruent, so they have equal measures. Okay. So what does this mean? Well, this means whenever we have two lines which intersect each other, we can get either linear pairs or vertical angles like we see here. The linear pairs are those two adjacent angles who have a sum of 180 degrees. So these are two adjacent angles whose sum is equal to 180 degrees. And then vertical angles are going to be the non-adjacent angles. Or the opposite angles. And these are going to be congruent to each other. So let's say that we had two lines that intersected like this. Okay? And let's say that I knew that this side was equal to 70 degrees. Okay. Well, let's use what we know about vertical angles, and we can actually find the other side. Let me name these A, B, C. Okay, so say we're looking for the measure of A, the measure of angle B, and the measure of angle C. Okay? And let's say this is all the information I'm given in my diagram. So I'm looking for the measure of A, B, and C. Well, I know that this angle is equal to 70. So what I can go ahead and do is I can derive from that my opposite angle, angle B, would also be equal to 70. Why? Because my vertical angles are congruent. But what about my other missing angles? Can I find the missing angles measures? Well, yes, I can. What I can do is I know that A in my 70-degree angle is a linear pair because they share that same line. So what I'm saying is that this angle and this angle are linear pairs, right? Because they share that same line and they share a common ray. This would be my common ray. So what I can do is use what I know about linear pairs, which is basically 180. They have to equal to a sum of 180. So 70 plus whatever angle A is has to equal to 180. So subtract 70. So A is equal to 110 degrees. So now I can plug that in. Okay, so now how do I find my measure of angle C? Well, I can go ahead and use my linear pair again, and I would see that B is a linear pair with C, or what I can do is now that I have A, I know that A's vertical angle or opposite angle is C, and so A and C have to be congruent. And so that also has to equal to 110. Whatever my preference is, if I wanted to do B and C being a linear pair, well then basically what I know is that B and C has to equal to 180 degrees because they share that common line and that common ray. And so I just plug in. I know this is 70. And I would see that C is equal to 110. So I could do it that way, or I know that C is the opposite angle of A, and so they have to be congruent, okay? So any questions about anything we learned today? Questions? Okay, so again, linear pairs are two adjacent angles that form a straight line. Adjacent meaning right next to each other. And the relationship is that the angle measures equal to 180 degrees. So if I add those two adjacent angles together, I have to get 180 degrees. Vertical angles, on the other hand, are opposite angles or non-adjacent angles, so they're not right next to each other, formed by two intersecting lines. And we know that if they're opposite angles or vertical angles, then they are congruent. Okay, so any questions? Okay, we'll go over some more examples of this tomorrow, but that's basically just the basics. So if there's no other questions, you guys may log off, and I'll see you guys tomorrow. Bye, guys.